All right, welcome to class 3. This is Monday, Tuesday class for week 2, CSE 224. So I want to run through some more commands today, just kind of, building out our set of Unix commands, but also seeing some different types of commands. I want to think more today about sort of Linux as a complete operating system instead of just this terminal window that we interact with. It's actually we're running on an operating system with lots of things going on. So I want to look at some commands related to that. So I'm still on the Linux server in my nMacias account. I've used my regular bash rc with my prompt and curly brackets so that I know I'm sitting on the server instead of my home machine. So one useful command is uptime. Uptime tells you how long the system's been up. So after spring quarter ended, I rebooted the machine, so this has only been up for 79 days. And it tells me there's 4 people logged into the system, and the load average tells me how busy the CPU is. And this is something like current, 1 minute and 5 minute or something like that, running averages. A load average of 0 means the system's not doing anything. A load average of 2 or 3 means it's pretty busy. A load average of 5, you're probably going to be noticing some delay. A load average of 7 or 8, your system's in bad shape. It's probably really struggling unless it's very, very high powered. On my own system at home, I've only been up for an hour. My load average is around 5 because I'm doing recording and a couple of cameras and things like that. So uptime is an interesting command. Who is another command. Who shows you who's logged into the system. So if I do who, I see 4 people on the system right now. There's nMacias, that's me. Here's some joker called Nick. Yeah, that's also me. And here's Goblin King. That's also me. And you can see when these people logged in, right? So 1149, 1148. You can see what IP address they logged in from. So this basically tells you what machine they're connecting from. And yeah, this is the IP address of my laptop here at home. You can say PS, and this will show you what processes you have running. So every time you type a command, there's a process being executed. When I type the PS command, guess what? I have a process called PS. I also have a process called bash. That's this shell. That's the program that's constantly running when I'm logged in, waiting for me to type something and generating responses. Now if I do ps-l, I get a larger display with more detail. I can see the identification of the person running this command. So nMacias, my user ID is 1002. These unique process IDs that tell you what the identity of this particular command is, and also what the identity of its parent is, the process that created this process. So PS is a command with ID 7091. It was created by 7066. Well, 7066, that's the bash command. So this is telling me that this bash program that's running right now created this process to execute PS. If I say ps-l again, it will show me the PS process that has a different process ID, 92 instead of 91, but its parent is still 7066. That's this bash process. And if I do ps-e, that'll show me every process on the system. So a lot of the idea of Linux is it's a very open system, right? It's very easy to look and see what every process is that's running on the system. I can see who's logged into the system and so on and so forth. Alright, the date command we've already played with as a sample command that shows us our current date and time. And we played with SFTP as a way to transfer files from one system to another. It's the file transfer version of SSH, which is the secure shell login. So most important command in all of Unix is cowsay. So if I say cowsay hello, I get a talking cow that says hello. This is a really useful command, right? It's useful because I could say, x equals this is a test, and I can say cowsay $X, and my cow will tell me the value of my variable. I can say cow say $path, and my cow tells me what my path is. So cow say is a useful command. WC, word count, is a useful command. So if I just say WC and I hit enter, I can type a bunch of stuff. And how do I specify the end of my input? Control D, as in dog. So I'm going to hold down Control and press D. That's the end of my input, and now WC gives me some information. The number 4, that means I had 4 lines. The number 9 means I had 9 words. This is a test, hello, what is happening, and typo. And 46 is the number of characters. Now, if I have a file containing some information, and I say word count and the name of the file, it will do the same thing on the file. So in this case, it told me my file had 5 lines, 9 words, and 47 characters. Well, what's the difference? I have an empty line here on the bottom. If I get rid of that and I say word count file, I get the exact same numbers as when I did word count on this interactive input. So word count takes a file name and tells you information about how many lines, words, and characters are in there. Or if you don't specify a file name, it just reads from your keyboard and gives you that information. And most Unix commands have this behavior. If they expect a file name and you don't give a file name, they will read from your keyboard and process on that instead of a file. Alright, so grep is a command for searching. And so if I say grep test file, it will search the contents of this thing called file, and it'll look for any line containing the word test. And it finds that first line. If I search for an E, it shows me 3 lines because each of those contains the letter E. If I search for an O, it only shows me hello and typo. So grep is a way to search a file without going into an editor. And you can give it a file name and tell it what you're looking for, and it will show you each of the lines that contain whatever this pattern was. Alright, df is a command for looking at disk space usage. So if I say df, it will show me all the places I have storage available. And the main storage we use on the server is mounted under /. That's the root of that file hierarchy we talked about in class 1. And it tells me that under / I'm using 31% of the available storage, which is 32 gigabytes. I've used 14.5 gigabytes, and the total size of storage available is about 50 gigabytes. And there's some smaller storage areas. These are called partitions. There's a boot partition, which is only about half a gigabyte, and it's using 166 meg. It's got 277 meg available. So if I move into the directory /boot, I'm actually in a separate area of the file system from just plain old /. But all of our /home, /username, all of /bin, and so on is sitting under this one / directory. And it's about 50 gig total space available. Alright, another useful command is watch. Watch is nice if you want to execute a command over and over again. So for example, if I say watch date, it will run the date command, and my default's going to run it every 2 seconds. So this is just re-executing this command and showing me the output of it right here. And it's, you know, just a little clock now sitting in the top of my window. But you can watch any command you want. I could say, I'm going to use Control-C to get out of that. I could say watch who, and it will show me the output of the who command updated every 2 seconds. And so if I come over here and I, am another user, and I go ahead and log in. So let me do an SSH and log in as myself here. And this display, which is automatically updating every 2 seconds, should, the next time it runs who, show me that there's a new user on the system. So now I'm logged in, and so there's the new user, and they just logged in at 12:01. So this is a useful command. Again, the command name is watch, and you can say watch followed by any command you like, and it'll rerun it periodically. And in our practice problems, you'll play with this and find ways to change the behavior of watch, and so on and so forth. Alright, so for this next part, I'm going to go back into my VirtualBox installation. So this is a fairly unadorned Linux setup. I'm going to Control Alt T to open a terminal window. I'll Control Scroll Wheel to make the text a little bigger. And here, if I say Caussay hello, I get a really sad message saying Caussay is not found. It's not part of the standard Linux setup, but you can install it. Now, you can't do this on the Linux server because you're not root on there, but on your own system, whether you're running VirtualBox or running on your own laptop or desktop, you can use this command apt install Caussay to install this command yourself. So I can say apt install Caussay, but I get a permission denied, right? Because even though I own this system, I need to be the administrator, I need to be the root user, so it's asking me, are you root? So, so a standard user cannot install or remove packages on the system. So what do we do about that? So I'm going to come over here, I'm going to hit the power button and say log out. And I'm going to log back in, but this time I'm going to log in as the user root. So I'm going to go to the drop down, say other, type in root, and you're going to use the same password that you set up for your own account when you created the Linux system. And so that should log me in as root. I'm going to Control Alt T to open a terminal window, and I'm producing videos in another part of my system, so this is going a little slow. And so here I'm going to say apt install Caussay. And for small commands, it will just go ahead and do this. For larger commands, sometimes it will ask you, are you sure you want to do this? And you say Y or N. So it will take a few seconds. It'll say processing triggers, and then I come back to my prompt. And so I'm going to log out of the root account and log back in as Nick. And then over here I'm going to Control Alt T to open the terminal window. And you can do this through drop down menus also. You can come down and find software or applications and so on. But I'm going to open this up, and now I'm just going to say Caussay hello, and there's my talking cow. So logging into root will get you there, but it's a pain to have to log out and log back into root. And we don't necessarily want to spend a lot of time logged in as root, because, for example, if you're in the / directory and you were to say rm-rf star, you would delete every file on the system until the system crashed. So we usually don't want to be sitting as a root user, but there's a command called sudo, and if we say sudo, we can type a command and it will temporarily execute that command as if we are the root user. And so, for example, I could say sudo apt install Caussay, and it'll ask me for my password, and it'll say Caussay is already the newest version. Whereas if I did this without saying sudo first, it would say, hey, permission denied, you're not root. So sudo is a handy command. Now by default you cannot sudo yourself, but there's a command called vi sudo that will let you give yourself sudo access. Ask me how to do that if you're curious. You don't need to do this very often, and so it's easy. It's just to log out and log into root if you want to install something. But you can add yourself to this super user do list. But that's not something we need to do right now. All right. What else do we want to do? We want to talk about file archives. So I don't have a lot of stuff in here. I've got some empty directories, but not a lot of stuff to work with. So let me go ahead and make some files. All right, so I've made myself some files to play with. So I'm sitting here under a subdirectory called work, and I have a few files and a few subdirectories. And if I look in homework 1, I can see some files in there. If I look in homework 2, we got some files there. So if you want to explore your entire directory tree, an easy way to do that is the find command. And if you just say find space period, it will start at your current directory and show you everything that it finds in your current directory or underneath. So file main, main.c are in my current, fun2 is under homework 1, grading is under homework 2, and so on. So suppose I wanted to copy all of these files in this directory structure to the Linux server. So I could go ahead and I could push these over one by one, and I could create directories with makedir and so on, but that's a pain. So what we're going to do is we're going to make a file archive, and the command we're going to use for that is tar, and the options we put on tar is going to be cvf. This means create a file, show us what you're doing, be verbose in your actions, and I'm going to tell you what to call the archive. That's what the F says. So I'm going to put this archive under my home directory. That's what tilde means. And I'm just going to call this work.tar. And then I'm going to list all the files that I want to put into it. And I'm just going to say period, which means my current directory. And by default, it will recurse down. So tar cvf tilde / work.tar space period. And I can see that it's added each of these files to my archive. So now if I go into my home directory and I do an ls-l, there's my work.tar. That's my archive file. And if I say tar tvf, t means show me the table of contents for work.tar, it'll show me what's inside my archive. And I can see, you know, I have some files at the top level, I have some files in some subdirectories. Now I'm going to transfer this file to the Linux server. So I'm going to say sftp and Macias at linux.engrcs.com. And, you know, first time you connect to a machine from another machine, you'll get this warning that it can't verify that I'm actually talking to the machine I think I am. Because I've never done this before. Now once I do this once, it will record a fingerprint so it can authenticate that machine. But the first time you connect, you have to have an element of trust. Alright, so now I'm going to put in my password, which I think is wrong. Oh, nope, there we go. Okay, and I'm just going to say put work.tar. And it'll say upload work.tar to /home and Macias. Going to do Control D to exit. And now I'm going to SSH to the Linux server. And now I'm on the Linux server. You can see my funny prompt there, which tells me I'm logged in as nmacias. And if I do an ls-l, hey, there's my work.tar. And I can do tar tvf work.tar. And I can see, you know, I've got a few files in the top level and I've got some subdirectories. So let me recreate this whole file hierarchy from this tar file. So I'm going to make dir, I'll just call it new work. I'll go into my new work directory and I'll say tar xvf, the X is for extract, / work.tar. And that's it. I've got my 4 files, file 1, 2, main, and main.c. I've got my 2 subdirectories, homework 1 and homework 2. And if I say find dot, I can see all of my files. And, you know, I just copy this entire file hierarchy. And I preserve the timestamps. Right now it's 12:15, but it knows that file 1 was created at 12:09. It knows that homework 1 was created at 12:10, and so on and so forth. It will preserve as much information as possible inside the file archive. And, you know, if for some reason I wanted to make a second archive, I can make a work2 and extract from work.tar. Got to be able to type though, right? And now in this work2 directory, I've got this whole file hierarchy. So now I have 2 copies of my project, right? I have work2 and I have new work, in addition to the copy that's sitting, you know, back on the server. So tar is a useful command for creating archives, and the 3 main ways we do this: tar cvf file.tar, and then a list of file names that creates; tar tvf, whatever our archive.tar is, that shows us the table of contents; and then tar xvf filename.tar, that extracts from the archive. And those are the 3 main ways that we're going to use tar. But of course, you know, you can look at the manual page on tar and see a lot of different switches that you can put in, and a lot of ways that you can modify it. But those 3 are a pretty good set of options. Alright, last thing I want to talk about is zipping. So I've got this this work.tar file, which is 10,240 bytes, right? I may want to make that smaller, and there's a compression utility we can use called gzip. And if I just say gzip work.tar, and then I do an ls-l, work.tar got replaced with work.tar.gz, which is only 418 bytes. And then if you want to unzip it, you can just gunzip work.tar.gz, and it'll get you back to your original. Now if I want to gzip my file with a really long name, I could say gzip this and hit a tab so I don't have to type all of that in. And right now this is a file with a long name, is 32 bytes long. If I do an ls-l, it actually grew to 81 bytes. So for small files, gzip's not necessarily going to make a smaller file. There's a limit to how much you compress. So I could unzip that and get back to my file that's 32 bytes long. But for, you know, larger files that are thousands or tens of thousands of bytes or megabytes or gigabytes, especially files that contain a lot of human readable text files, gzip will do a nice job of squeezing it down, saving a lot of space. Alright, so we're going to play around with all these commands in class.